Greetings to all. This is R. Ganesan, Assistant Professor, Kamaraj College of Engineering and Technology. Today I am going to take the class Ybus Formation by two-rule method. Ybus Formation is a vital role play in a power system analysis, in a load flow analysis. In power system analysis, it's a heavy subject. In that, we are studying load flow analysis for calculation of bus, power, real power, reactive power, as one as, and fault current analysis. So that we need a Ybus to form large number of system. For example, one or two bus system means we need not to find about the Ybus formation, but in large number of n number of bus system we are going to analyze means we need to find Ybus, that means admittance in a matrix format, that is Ybus. So, we are going to form this by two-rule method. What are other methods are available means direct method, singular transformation method. We will see one by one. So, today we are going to see Ybus formation by two-rule method. So, what is bus admittance matrix? That means Ybus. So, the bus admittance matrix is a matrix which contains the admittance value of bus flow between the self and mutual admittance value. It used to analyze power system problems as well as the load flow analysis. Okay. For example, we know the equation for three-phase system. Sorry, V equal to I into Z. V equal I into Z. This is the formal equation for AC system, but we are going to calculate current is depend on what load we are connecting. So, the equation is defined as I equal to V by Z. That means I am going to rewrite this equation 1 by Z into V equal to I. This is the equation, because in power flow studies, in bus bar arrangement, in generating station, in transmission and distribution, the voltage level never change. We can step up or step down for the bus system, and it maintain as a constant for the particular system. So, we never change this. And the connecting between bus 1 to 2 or bus 1 to n, the value of impedance define the value of current. That means how much load we are going to connect, the current will change. So, here I am writing 1 by Z, that means the reciprocal of impedance is called as admittance value Y into V equal to I. I am going to convert this as matrix format for n bus system. So, for analysis of voltage, current or power, that means real and reactive power, we need to form Y value, that means Ybus value. So, first initially we are going to form the Ybus by using two-rule method. What is the two-rule method? The two rule is one is self admittance, another one is mutual admittance. For n number of bus systems connected means we are taking 1 to 5 bus means Y for bus system, for first bus system it contains its own admittance value as well as it will be mutually connected between neighbor bus system. So, we are going to calculate this value. Second is mutual admittance. So, this is between 1 and 2 and 2 and 1, either 2 in between the two bus system, it is called as mutual admittance value. So, two rule of self admittance, the first rule is the diagonal elements of the Ybus, the diagonal element of the Ybus. That means when we are going to construct the matrix, the diagonal element of the Ybus is called as self admittance value. So, it defines the formula YII, that means it is a diagonal element called as sum of all admittance connected to bus I. That means that particular bus, how much amount of admittance value connected, we are going to calculate the sum value. So, the sum of all admittance connected to the bus which is 1 or 2 or 3, all the value we are going to sum, that is YII. It is a first rule. So, it is self admittance or diagonal element of Ybus matrix. The second rule, major rule, is mutual admittance, rule of mutual admittance, which is called as in between two buses. So, that is called as mutual admittance. So, the negative sum of connecting between the two exceeding buses is called as mutual admittance rule. So, we are taking Yij, that means Y122, Y123 means in between Y122 or Y123, what are the admittance value there, we are going to sum and put a sign negative because it is a mutual. So, we are providing the negative sign. So, that is mutual admittance of the branch or branch admittance for the element. So, these are the two rules. The first rule is we are going to self admittance, second rule is we are going to calculate mutual admittance. For example, I am going to take one simple example with the 4 bus system having the R value and reactance value with half line charging admittance. Here they provided half line charging admittance. If they given full line charging admittance value means we are going to take half value, but in this problem they are providing V by 2 value directly. So, we can take this value directly. Okay. In this problem what we are going to do means by using two rule method we are going to calculate Ybus. So, first we need to calculate Ybus means we are going to use two rule, one is self admittance and another one is mutual admittance. By using that we are going to construct the Ybus matrix. So, for that matrix dimension we need to know what is the matrix dimension means. First, what are the maximum bus number is there, that is the matrix dimension. For example, the number of buses n means n is equal to 4 means the matrix dimension is 4 cross 4. So, initially we need to fix this. So, matrix dimension is 4 cross 4. Then what is the value they given, the between 1 and 2, 1 and 3 they what they are provide. You need to check this. If it is admittance value means there is no issue. If they are given in impedance value means you need to change into admittance value. So, second step is you need to change what are the impedance values are there. You are going to take y is equal to 1 by set formula. You are going to change the impedance into admittance value. So, after that we are going to proceed two rules. So, first initially we need to fix the matrix dimension. After that, if the value are an impedance means we are going to convert into the admittance value. So, initially I am going to convert the each and every element from bus 1 to 2, 1 to 3 and 1 to 4, 3 to 4. I am converting that impedance value in admittance value by using the formula 1 divided by that admittance value. So, 1 divided by 0.02 plus j 0.06 equal to 5 minus j 15. This is between 1 and 2 which is admittance value. This is y 1 and 2, this is y 1 and 3 value, this is y 2 and 3 value. I am providing here capital letter y 3 and 4. So, these 4 values are they are given, and after that they provided in table admittance value also, half line charging admittance value also we are going to take into account that value too. So, next step we are going to write the Ybus matrix with the element 4 cross 4. So, y 1 1, y 1 2, y 1 3, y 1 4 and y 2 1, y 3 1, y 4 1. Likewise, we are going to fill all the matrix 2 2, y 2 3, y 2 4, y 3 2, y 3 3, y 3 4, y 4 2, y 4 3, y 4 4. This is overall Ybus. We are need to find the diagonal element by using rule 1 and the off diagonal element by using rule 2 mutual admittance value. That is our aim. So, y 1 1 formula is sum of all the value connected in the bus. So, I am going to draw the network. So, here we know the value. So, I am going to draw the network. What is the network? Totally 4 bus system. So, 1, 2, 3, 4, 4 bus system. So, 1 to 2 the value is here they are providing 5 minus j 15, 1 to 2. So, 1 to 2, here I am taking this bus as 1, this bus as 2, 3 and 4. So, 1 to 2 5 minus j 12, they are 5 minus j 15, they provide that value. We find the admittance value from impedance. Likewise, in 1 to 3 10 minus j 30, 1 to 3 10 minus j 13. sorry 30 and 4 minus J20 is 223. 223, the symbol of line charging admittance value is 1 capacitor, line charging capacitance with ground. So, I am providing this, the value is 0.03. So, this value is common to second bus also, 0.03 J. Likewise, I am going to write all the buses, that is for second bus. In bus 1 also another one line charging value which is 0.02. So, here I am providing 0.02, 0.02 J, that is common to bus 3, 0.02 J. And for bus 2 and 3, bus 2 and 3 the value is 0.01 J, here also 0.01 J. Again 3 to 4, 3 to 4 value, here I am writing the value of all half line charging admittance value. After that we go for that slide, it will clearly shows what are the values are there. So, here the complete network is there. So, we are going to write each and every value from this diagram. Okay. So, in this the diagonal element y11 we need y11 and y22, y33, y44. In y11 we need, the rule is sum of all admittance value connected in that particular bus. Here this is bus to bus. So, here the connected values are 1, 2, 2 mutual admittance as well as 2 half line charging admittance value. So, total of that 4 value is called as y11. That means, I am going to it connected by 1 y12 plus y13 plus y10, that means 120 plus again another y120. So, these 4 elements need to sum to get y11 value. Okay. So, likewise y22, y22 means here I am going to calculate the self admittance value of second bus. Okay. So, here the elements are 5 minus J5, J15 plus here 4 minus J20 as well as plus 0.03 J plus 0.01 J, these 4 elements. For y22 these 4 element I need to sum y22. For y33 again I am going to that bus which has 3 major element mutual admittance as well as 3 line charging admittance value. So, totally 6 elements I am going to sum. For that bus y123 mutual admittance value and y223 also having one mutual admittance, y324 also having one mutual admittance as well as line charging admittance value, how much are there? 3 elements are there. So, I am going to calculate this 6 element, I am getting y33 value. Likewise, y44 value only having one line charging admittance and one mutual admittance. So, only 2 elements are there for y44. So, likewise only we are going to calculate in calculator mode, we are provide at complex mode, after that sum that value. So, this is self admittance rule 1. For mutual admittance for rule 2, for the off diagonal element like y12 which is equal to for symmetrical matrix y21, that means the negative value of what we are writing in y12, that is the rule. Likewise, if minus y12 means we never taken the half line charging admittance value for the mutual admittance, because it is calculated under rule 1 for the self admittance value. Okay. So, in mutual admittance means 1 to 2 which are the elements connected, we are going to take negative value, that means minus 5 plus J15, this is the value. Likewise, we are going to calculate all the element y12, y13, y14, y21, this is same, as well as y23, y34, y31, y41. These are the off diagonal element we are going to calculate by this way. What are the elements connected between 1 to 2? 1 2 3. If 1 2 3 means here the bus system 1 and that bus, the connector value is 10 minus 30j. So if y13, I am writing y13 means negative sum of value. So 10 minus 10 plus j 30. Likewise y14 value, here 1 to 4 there is no element, so we just put 0, which is also y41. Likewise we need to write all the elements. This is the two rule method. For the first rule method we are going to calculate the diagonal element which using self admittance value. After that the mutual admittance value for the off diagonal element we are going to take negative sum value, then we will get the value of this bus system. The value, the overall answer for this problem we can get like this from the bus to bus. This is y11, y12, y13 and then y14, because there is no element in between y14. Likewise we are going to write all the admittance value. So this is the two rule method. Short summary about this method is, one is y11, y22, y33 we are going to calculate what are the element connected in that bus, which including the line charging admittance value. After that we are going to calculate the mutual admittance value, means we need to take bus 1 to 2, what are the elements in between them, we are going to take negative sum of that value only. So this is simple example for this. We can see the next problem, next session, singular transformation method for forming Ybus. Thank you.